Hello, welcome to Bedroom Builds at the rsytup series episode 1 date math, where we will be implementing the math or the functions necessary to do some date computations. The first thing we will build is, of course, parsing the standard ISO date format, because the input from the command line interface will be a string. Then for myself, I needed the feature to compute the upcoming weekday. So for example, if you want to release your videos on a Friday, you want to be able to compute the upcoming Friday without having to look into a calendar and stuff like that. So this can be generalized, of course, so we can also compute the upcoming Mondays, Wednesdays, and whatnot. And for users that have episode numbers and a known start date of when the series started, they can actually use the episode number to compute the release date. And for this, we will also provide the functionality. In order to do all those date computations in Rust, the chrono crate is fairly useful. So we will be using this one today. Let's hop over to the code and the shell to start coding. As you can see, the main file is already open, but we want to have the shell available because the first thing we will need to do is, since we are on the main branch and we are implementing a new feature, we are going to start with a new branch. One way to do this is git checkout the b for branch name, and then we use date compute, for example. And this way we have our new branch active, as Starship shows us here. Once we started with that, we can close the shell again and get away hacking. Since we are doing a math for dates, this is not supposed to be in the main file. We will create a new module. Let's open up a new file called src date compute rs, for example. And once we have that, we have a completely new file. And what we want to do first is write tests for what we are going to build afterwards. Tests in Rust are fairly easy to write. All we have to do is create a module inside the same file, which I'll be doing here, or you can create, of course, a completely separate file only for your tests. But in order to let Cargo know which ones are your tests, you have to use this configure test attribute. Once we have written this, we can now start our module. So we will be very creative and call it tests. Once we have that, we will have to import all the things that we have defined in the module externally. In our case, our date compute. So this is now all a boilerplate to write tests, but that's needed. I cannot change that. And we can write our first test, which will be computing the coming weekdays. So coming weekdays is the test name. All of this is not test-driven development, but gives us a good idea of what we have to implement. So if we have a Thursday, for example, then we need to parse it first because we're starting off with a string. So we'll probably create a function that's called like parse ISO date, maybe. Once we have that, we put an ISO date in there. So we have 2021, September 02 is a Thursday. This will make it very easy for us to compute what's Friday. So all we have to do now is create a Friday, but this we now use with our coming weekday function that takes the Thursday as an input. And since we want to be able to design which weekday we want to have, we will have to use some enum like that maybe. And once we have that, we can now actually write our first test, which would be assert equal. And once we have that, we can now put our comparison in there. So we want to compare the Friday to an actual Friday. So we will use our parse ISO date again, but this time with the date of Friday. Once we have written this, we can now run cargo test, which will look like that. Cargo test. And nothing much happens. Why? Because this is just a new file that we created, but cargo doesn't know about it because we have not referenced it in our main. So let's quickly do that. We will have to go to our main file and make mod date compute part of our binary. We write this out, we go to the shell, we run cargo test, and hurrah, we have failures because of course we haven't implemented the functions yet. These tests do not compile. Let's close the shell again, hop over to our buffer with our code, and the first thing we want to implement is the parse ISO date. For this, we will have to use chrono, and since I have already written this code, I can kind of know what I want to use already. So we will use weekday from chrono. We will definitely use naive date because the parsing we will do into a naive date format. And from there, we can start implementing our ISO date. What's immediately missing now, the Rust analyzer is telling us, well, this is an unresolved import. We don't have the chrono package yet in our cargo toml. There is a very easy way to do this. When you have cargo edit installed, you can now do this. We go cargo add chrono, and that's it. That's all we have to do. Now we have chrono installed. We are creating a module to be used by other parts of our code, so we have to make this public function parse ISO date. And this function, of course, has to accept string slice, because this is a string that will be coming from the command line parsing interface. We want to return a result that gives us our naive date. And since we can have an error, we know that the chrono has already a parse error class implemented for us. We will use that. So now all we have to do is call the naive date. This will be our date that was passed as the string, and now we need to make sure we have the right formatting, so it will be year, month, day. And we remove the semicolon because this is all we have to write. So now we have our first function, but we might want to document that for the users of this thing. So we will have a naive date from ISO 8601 strings. So now we can actually run the first test, but we can see that this will not work because here we are returning a result. So we actually have to unwrap that. We can be sure that our formatting is okay, and the same will be in our test. Let's see what happens if we now run cargo test. It now compiles chrono, and of course complains we haven't implemented coming weekday yet. But not to worry, let's quickly do this as well. We will have to also pub fn upcoming weekday. The input will be a date, a naive date to be precise. So we will call this our starting date, which will be of type naive date. And we want to use the enum of the weekday to know which one we want to find. So we go weekday is of type weekday, and this should return a naive date since we actually have the input of a valid date already and a validated enum of weekday. We do not really produce any errors normally, so we can directly return the naive date. So what does this actually do? Well, let's write documentation, then we know. So this computes the next upcoming requested weekday from start date. The dumbest algorithm to do this is, of course, if today is the weekday that we are looking for, then we will have to add a week because then we want to have the upcoming Friday. So if today's would be Friday, we want to have the next Friday. And all the other days means that we have to iterate over tomorrow and after tomorrow until we find a weekday that matches our desired weekday. Now, how can we pull this off? We would have to first figure out if the chrono library provides us that. Let's jump into their documentation, which is here. So I'll zoom in and let's see what happens if we type a weekday here. So there we would have chrono weekday is the day of the week, right? And now here, cool, naive date has a weekday function. Let's click on that. So what does this do? It is a method that returns us a weekday. So we can use this in our code to figure out the current weekday. Therefore, as I said before, if start weekday equals to our passed in weekday, then we want to add a week. But how do we add a week? Well, first of all, we want to return because we're doing math right away. And we will use our start date for sure. And we want to add a week. So how would this work the easiest way? Well, chrono provides also that. Let's check the documentation if they have duration. And they do. So what does chrono duration do? Here we can actually quickly see we can have weeks and days and hours. All we have to do is provide a number and this will give us a duration and then we can do math with that. So chrono duration it is. We can type this out directly. We will only use it here as of now at least. And weeks 1. And there we go. We have our return for the next weekday if the weekday happens to be on the day when we check this. And now for our silly loop, we want to be able to go from today to the next day already, because in our first condition we already checked for the weekday of today, so we can be sure that now is not the same day. Now what we will need is to loop. Normally in Rust, the interfaces of most crates will provide you an iterator. So let's check for iterators. In the documentation, I will type iter because that's normally already good. And here we go. Actually, naive date has iter days. The documentation for iter days tells us what it does and gives us a naive date days iterator. And here is a nice example code. So if we have this iter days, this gives us an iterator, and here they use take 4, so they take 4 days and then they enumerate over them. and produce output. So that's the way to use it. We already have a naive date, so let's use iter days and loop over this. Rust is easy, right? So we write for day in start iter days, and once we have that, we know that the maximum we want to go over is a week, and not even that, because we just checked that the weekday is not the same. So we make at most 6 next days as our test condition, and now we already know what to do if the weekday equals, oh, forgot the braces, to our desired weekday. We again curly braces return the d that we found. So let's write this out. Now the compiler will complain because our function doesn't have a return value on any case. So in error case, I simply return the start date, which is probably not the smartest way of doing things. But now we have calmed down the compiler with obvious problems. Let's try to run our test again. This time, cargo test. It doesn't work, and the reason is fairly nicely explained in the error message, which is the awesome part of Rust. So it complains that in our, for example, comparison here for if d is weekday, it doesn't have this method for naive date. The reason is because we just found it in the documentation, right? That this is part of a trait. So if you want to use the trait, we have to import it, and the compiler even gives us a hint. So we have to use this chrono date-like trait. That's very easy to do. Let's hop up into the code. First line, we will have to use the date-like trait. Once we have stored that, we jump back into the console, run cargo test, and we have our one test that turns out to be okay. So what we can implement next, for example, is a simple add weeks function. So now we have the new function, but no documentation for the function. Cool, so now we have this add weeks function, but it probably makes sense to verify that this add weeks function works. So let's write a test. Once we have that, we should be able to run the test, and we should have 2 tests that are not failing. Let's see if that is true. Cargo test. And now we have 2 tests that pass. Very good. Let's go back to our editor. We actually have 2 things that can happen in the coming weeks days. So we should test for the second thing as well. So here it goes from a Thursday to a Friday, but we also want to test what happens if we actually put a Friday as an input. It should add a week, correct? So let's copy those lines and do the already Friday check. So here we will have to now go ahead and use already Friday. And we change the date to the 3rd because we know that this is a Friday. Then we run the function. We find the next Friday, but now this should be the 10th. This way we can test if our function does the exception. Now the only thing missing is you can also influence the time of day when your video is posted. So instead of just providing the date, we might want to also provide the date time. For this, we have to write yet another parser, or well, the same thing that we wrote for the normal day, but now with our time formatting added. Let's do that then. So we have our naive date, and now we need to have a time added. Luckily, they provide this to us with the naive date time, and we wanna be able to have the time information to be optional. So this now returns a naive date time, of course, and we want to change the function name to naive date time as well. Once we have that, we change this as well. Now we have the date coming in as a string and the formatting, and here we miss the time. Now, the formatting is hours, minutes, seconds, which is not the perfect ISO string because there should be a T in the middle, but almost nobody uses that here. So I stick with that for now. The thing is though, how do we make the time optional? The easiest is actually to figure out if the string contains time, and if it does not, we simply add, for example, midnight. Let's quickly code this up. So now we have the time added as an alternative to have the time optional. This way we can parse the naive date time as well. Since we have now written this, we have to also write a test. Those two Thursdays, that should be the same because we parsed one with a time and one without a time. This way we actually test both functionalities. And there we go. Let's quickly hop over to our console, clear it, run the tests. And it doesn't like us because we have not imported date time. That is very true. But we can quickly fix that. On the very top, we add naive date time. So now should be happy. It is not, because I have not provided a slice to our parsing function. That's an easy fix as well. We made an error in our code. That's no good. So we haven't used weeks in our add weeks function, which is true because I copied the code over and didn't use the weeks. It's hard coded to 1 as I64, and so one of our tests is failing, which makes a lot of sense because we haven't really added to our already Friday week. So we have to do the already Friday. So we finally have working tests after ironing out the last niggles. Let's check out what's happened to our source code. So if we go git status, we can see that cargo toml was modified, the main RS was modified, and we have a new file called date compute. So let's first check what happened to cargo toml and the main RS. So we can do that with git diff, and you can see that my cargo add command did add this line for us with the correct version number and the chrono package. And this one we added manually to have the date compute be part of our modules in our crate. So what we can do now is add the stuff that we just wrote, which will be git add source date compute. And since we have modified the main RS and the cargo toml, we add that too. Now with get status, we can verify that all the changes that we want to commit are in the to be committed list. Let's run the commit. Implemented date computation. Oops. Module. This is our amazing commit message. We have done that. And all we have to do now is merge that to main and push it, or push the branch as is. But since we are happy with what we built and all the tests work, we can actually merge that to main. So what I usually do is I would git checkout main, git merge date compute. And once that happened, we can actually git push that. Thanks for watching. Coming up next on the rsytup series will be command line parsing, where we will be directly using different options that we just implemented for the date compute with the command line parser.